In this question, it is given that let S1 equal to the set of complex numbers such that mod of Z1 minus 3 equal to 1 by 2 and S2 represent the set of complex numbers such that this condition is true, and supposing Z1 is a complex number belonging to S1, Z2 is a complex number belonging to S2, you have to find the minimum value of mod of Z2 minus Z1. That is, we can say minimum distance between 2 points, one of which lies in this region, other lies in this region. This equation clearly represents the set of all the points which are at a distance of 1 by 2 from the complex number 3. 3, 0 and radius 1 by 2. All the complex numbers which lie on this circle, it has radius 1 by 2, will satisfy this condition, that is belong to the set S1. The set of points belonging to S2 are a bit difficult to find. The set of complex numbers belonging to S2, that is which satisfy this condition, I mean to say, to draw the graph of this seems to be a bit difficult to draw. But if you proceed in proper way, then it is not that much difficult. We know that mod of Z1 minus Z2 whole square is equal to mod Z1 square plus mod Z2 square minus 2 times real part of Z1 Z2 bar. Similarly, if it is plus here, plus will come here. Keeping this formula in mind, note that here I can write Z1 Z2 bar, or I can also write Z1 bar Z2. Real part of both of them are same. Now to draw the graph of S2, first I square both sides and then use these two formulas of minus and plus. Now squaring both sides and using these formulas, I get mod of Z2 minus mod of Z2 plus 1 whole square equal to mod of Z2 plus mod of Z2 minus 1 whole square. And now using the previous formula, I get mod of Z2 whole square plus mod of Z2 plus 1 whole square minus 2 times real part of this into bar of this, or this into bar of this. But bar of this is same as this, therefore I will preferably write this into bar of this, that is Z2 into mod of Z2 plus 1. This is equal to mod Z2 square plus mod of Z2 minus 1 square plus 2 times real part of Z2 into mod of note that this is a real number, therefore bar of this will be same as this. Clearly this will get cancelled and I get now mod of Z2 plus 1 whole square minus mod of Z2 minus 1 whole square equal to 2 times real part of Z2 into mod of Z2 minus 1 plus Z2 into mod of Z2 plus 1, that is mod of z2 plus 1 whole square minus mod of z2 minus 1 whole square equal to 2 times real part of z mod of z2 minus 1 plus mod of and note that this is a positive real number. Therefore, this can come easily outside. You will get mod of z2 plus 1 whole square mod of z2 minus 1 whole square equal to mod of z2 minus 1 plus mod of z2 plus 1 and this into real part of z2. This implies that mod z2 square plus 1 plus 2 times real part of z2 into 1 bar is 1 minus mod z2 square plus 1 minus 2 times real part of z2 into 1 bar is 1. This is equal to 2 into mod of z2 minus 1 plus mod of z2 plus 1 into real part of z2. This implies that after simplification I will get 4 times real part of z2 equal to 2 times mod of z2 minus 1 plus mod of z2 plus 1 into real part of z2. And now after this some of the students may think that let us divide by real part of z2, but no, we are allowed to divide by only that quantity which is sure to be non-zero, because real part of z2 can be 0 also. Therefore, if you want to divide, you will have to take two cases. First case, suppose real part of z2 is non-zero, and second case, if real part of z2 is equal 0. If real part of z2 is non-zero, we are allowed to divide by 2 times real part of z2. I'll get 2 equal to mod of z2 minus 1 plus mod of z2 plus 1. And if real part of z2 is 0, then automatically the two are always equal. Hence, one part of the answer I have got is real part of z2. That is, this equation will be satisfied by the complex numbers which are purely imaginary. Or second possibility is this. This means mod of z2 minus 1 plus mod of z2 minus 1 is equal to 2. That is, I can say sum of the distance of z2 from 1 and z2 from minus 1, sum is 2. That is, 1 is here, minus 1 is here, and z is a moving point such that this distance plus this distance is 2. But this is already 2. Therefore, if z2 is outside, then this plus this can never be 2. Therefore, to satisfy this condition, z2 will have to be on the line segment AB only, excluding the point beyond A or this side of B. Only all the points lying on the line segment AB, including endpoints will satisfy this condition. That is, so far I have concluded that all the points lying on y-axis or all these points belonging to the set S2, and the set S1 was the set of complex numbers which were having center at 30 and radius 1 by 2. That is, this point will be 2.5 and this will be 3.5. Let us draw a yellow circle. Now we have to find the least distance between a point marked by yellow line here and the points marked by yellow circle here. It is clear that the least distance between the point between 2 points, one belonging to this, other belonging to this, is this much. This point has x coordinate 2.5, this has x coordinate 1, therefore the distance this becomes 1.5. Hence I can say C becomes the correct choice.